I am very happy to introduce Professor Edwin HUTCHINS, who's a professor emeritus in the Department of Cognitive Science at the University of California, San Diego. He's also a MacArthur Foundation Fellow and a Fellow of the Cognitive Science Society. So Professor HUTCHINS, thank you so much for joining us here in Paris during this month. And please feel free to share your screen.
All right. Well, it's an honor for me to be here this afternoon at the Institute. For more than 50 years, I've been trying to figure out how people think in the wild. And I've developed a method that I call cognitive ethnography. And what that is basically regular ethnography as most anthropologists practice it, plus a recording of some naturally occurring activity, followed by a fine-scale analysis of the details of that activity. The analysis proceeds from some kind of a framework for interpretation that directs the analysis attention to certain cognitive aspects. Over the years, the technologies for recording have improved a great deal. And of course, the interpretive frameworks have evolved over time. Today, generative AI is a rising model of the function of the brain. At the societal level, it's a disruptive technology, and it's also disruptive in the social sciences. For my residency here, I'm hoping to explore one way that generative AI could change or improve the way that I do cognitive ethnography. When I started out in the 1970s, it was widely believed that primitive technology implied primitive thought. And this was a standard finding in cross-cultural psychology that adults in third world nations, illiterate farmers and fishermen, scored about like 10-year-old children in the Western world score on IQ tests. And in 1973, in fact, I was part of an expedition to Manus district in Papua New Guinea, where we replicated the expected result. But something didn't seem right to me. People seemed quite smart when I interacted with them on a daily basis. So in 1975, I went back to Papua New Guinea and armed with schema theory and propositional calculus as my interpretive framework, I sought to understand something about how Trobriand Islanders reason in their everyday lives. Now, the Trobriands was an interesting choice, I think a good choice for me. It was made famous by Bronislaw Malinowski, who basically fathered anthropological field methods in his work there 60 years before I was there. It was also important because other writers using Malinowski's work had concluded that Trobriand Islanders could not reason. So I went, I learned the language, I did the ethnography, I tried to understand gardening practices, identified 7 schemas for the transfer of rights in land. I documented the history of the people and the land parcels in question in each of the court cases that I analyzed. And you can see me here in this photo wearing my state-of-the-art 11-pound Sony audio recorder. And in this little excerpt that you're seeing here, after the recording, I transcribe. You can see a little transcription, and then I translate, but I don't translate into English. I translate into propositional calculus. And when we assign people and things and events to the slots in a schema, we get propositions that have a truth value, and they have logical relations among them. And in the little excerpt I'm just showing on this slide, this actually turns out to be an instance of what's called modus tollens reasoning. It's a strong inference. And I was able to conclude from this that, in fact, by analyzing a bunch of these cases, that they make the same inferences that we make. Trobriand Islanders are as logical or not as your average American or European adult. And I wrote this up in a book called Culture and Inference in 1980. In the early 80s, I was working for the US Navy, which gave me access to the navigation bridge on Navy ships. And so again, I undertook some work on the history and ethnography of ship navigation. I added video recording to my toolbox at this point, and armed with information processing psychology and the idea of a physical symbol system as a basis for AI, I went out into the wild of ship navigation to see what I could learn about individual navigators' cognition. And I got kind of a surprise when I got aboard ship. It turned out the physical symbol system was present, but it wasn't, as far as I could tell, inside any navigator. Instead, the outcomes that mattered to the ship were determined by the properties of the entire navigation team working together and with their tools. So the physical symbol system was there, but it was not where we expected to find it. And this idea that this larger socio-technical system had its own cognitive properties was the beginning of my approach that I call distributed cognition. In the 90s, I carried on with this same line of thinking with distributed cognition, moved into the aviation domain. My funder at NASA told me that the cockpit of an airplane is like the bridge of a ship, only it's moving about 50 times faster. And the same thing prevailed here. We could find how this system that consists of two pilots and the airplane was a cognitive system with its own properties, and we could track the propagation of representations around through this system. And the nice thing about the airplane world, of course, is that in addition to the actual observations in flight, which I made hundreds of flights sitting in the jump seat looking over the shoulders of pilots, in the aviation world, we also have simulators, and we can take video and record all kinds of simulator data while we're watching what the pilots do. Through the 1990s, the technologies for recording and representing and analyzing data improved rapidly. At this time, inexpensive digital video became available, and this was a complete game changer for all of the fields that were interested in the focus of activity, real-world activity and interaction. Together with Jim Holland in my laboratory at UCSD, we developed what we called a digital ethnographer's workbench. On this slide, this is an example of a sort of hyper field note where we have our ordinary field notes, but we also have live links to all of the documents that the flight crew consulted during the course of the flight. This work was funded by NSF and also by Boeing through Boeing's Flight Deck Concept Center, which is led by my former student, Barbara Holder. Also, I think the most powerful tool in our digital ethnographer's workbench is a video analysis tool called Chronovis that was developed by one of Jim's students, Adam Faust. And in the upper right, you can see a Chronovis display screen. Here we have 3 videos across the top, plus 3 timelines. And the important thing about this is that every timeline is both the display and the control. So you can move through that in time, and all the other displays, including the video, remain synchronized. So we had digital cognitive ethnography, digital field notes, and now we could record audio plus video. And again, made possible by Barbara Holder at Boeing, we could get in the simulators with eye tracking. So we had, I think, quite a powerful set of tools. On the lower right, you see 2 Boeing test pilots in a 787 Dreamliner cockpit, and they are wearing, at that time, state-of-the-art eye tracking goggles. In the new century, frameworks for interpreting cognition changed as well. And we saw the rise of embodied cognition, the inaction approach here in Europe, dynamical systems approach to ecological psychology, gesture studies, multimodal interaction, and le corps d'action approach developed here in Paris by Jacques Turreau, among others. So what does generative AI have to do with any of this? Well, I imagine a framework for cognitive processing that is multimodal, generative, and continuous. By multimodal, I mean the standard big five of vision, audition, touch, taste, and smell, but also proprioception, vestibular sense, haptic senses. We apparently have a lot of interoceptive perception that covers our internal states. And of course, there are many motor systems. And also on top of these, we have higher level representations where we find the integration of these things. So multimodality means lots of modalities that bring the organism into contact with its environment. What about, oh, and I should say, this is not exactly the same thing as the talk and gesture multimodality that we see in interaction studies, nor is it the same thing as text image multimodality of current generative AI. And it's my belief that as of today, AI in robotics doesn't quite get to the kind of multimodality that I'm talking about here, but I think it's going to be there soon. These fields are moving so fast. So what do I mean by generative? Well, these are ideas that are actually being explored a lot by Andy Clark in a new project that he has. But we have this notion that our internal processing is continuously producing predictions or expectations or imagination of what is out in the world. And when those predictions and expectations meet sensation, they settle into a match. And it might be that they have to change the perception in order to produce the match, or the internal structure has to change to accommodate whatever is in sensation. But sensation and prediction come to settle into a match, and that would be giving rise to perception. So I imagine this as top-down processing meets sensation. We also learn from experience. These AI models are really good at learning from experience. And for humans, it's my belief that the experiential world of humans is just saturated with culture. So we learn culture. And in fact, generative AI systems, your chatbots, ChatGPT, that learns culture. And in fact, I've used ChatGPT as if it were an anthropological informant. And it has somehow learned, although not explicitly represented, the major cultural models of Western culture. It has somehow extracted those from the massive training data that it gets. And it's a pretty good informant. It's a little bit conservative, but I could replicate all of the things we did as cognitive anthropologists in the 70s and 80s as far as eliciting judgments from people. We can now elicit that from a good, well-trained chatbot. And from my point of view, although many people are concerned about societal effects of generative AI, it has the virtue for me that it moves our attention from what are essentially unknowable internal processes to the observable activities at the organism environment boundary. One of my friends recently told me that the most recent version of ChatGPT-4 has about 1 trillion parameters. So we don't know exactly how those parameters do what they do. And we don't need to. We want to focus on what's happening at the organism environment boundary. And it's continuous. Back in the 80s, we used to say the mind is always on. All of these modalities are always on. Organism, environment. Coupling is continuous rather than stepwise. So don't think anymore about input and output. Don't even think about loops. We're just thinking about a continuous process that's continuously settling in to an interpretation that matches expectation to sensation. So imagine that world. Imagine a world populated by lots of people who all have this multimodal, generative, continuous structure. And let me illustrate what we might see in that world. Here's a new way of seeing. Let's go back to some of my previous data and see what we might see. On the bridge of the ship, I know this is all obsolete technology now. The US doesn't even publish paper charts anymore. But on the bridge of a ship, to establish the position of a ship, one can find the bearing of a known landmark in the world and draw a line in space with that bearing, and the ship has to be on that line. If you have two lines, the ship has to be where those two lines cross, so you fixed its position. Navigators are conservative, so they like to have a third line, and that makes a little triangle. And in general, the navigator's anxiety is proportional to the area of that triangle. You want a little one. Also notice the angles of intersection of the lines. That's going to be important in just a moment. A generative approach is a really nice way to highlight the role of culture. If you look at that chart, it is layer upon layer upon layer of cultural structure. There are frames of reference. There is directional grids. There are chart projections. You can see they're also charted what are called cultural features, where there are buildings. You can see what's land, what's water, how deep the water is, all of that stuff, all cultural constructs. On the left, you see a navigator with the plotting tool. And one of the cool things now is, because the chart is such a rich cultural world, the movement of the navigator's body acquires conceptual meaning. Movement of that plotting tool away from the body is movement north in the charted world. Rotation of the plotting arm around the protractor base is a change in direction, and increasing number on a scale. So let's, oh yeah, I've forgotten how clever I was. Let's consider something called the 3-minute rule. This is a trick in the navigator's world. On the upper right, you see a bit of a chart, and it's the navigator is spanning a little span with those dividers. That's the span between two position fixes that were made 3 minutes apart. And it turns out that the speed of a ship expressed in nautical miles per hour is equal to the number of hundreds of yards it covers in 3 minutes. And what's really handy about that is, in that upper photo on the right, that span could be seen as a distance. Of course, it's a distance in space, but it could also be a time. Say, this is where the ship was at the beginning of this 3-minute period, and here's where it is 3 minutes later. Now we lift those dividers off the chart and we take it to a yard scale. And now we could read it again as a distance. We could say, well, how many 100 yards did the ship travel in that period? But we could also read that as a speed, because the number of hundreds of yards it traveled in 3 minutes is its speed in knots. So here's an interesting thing. You have a single span, a single visual array, and it could mean the distance, it could mean the time, or it could mean the speed, depending on how we see it and what cultural background we see it against. Yeah, too smart for my own good. And that's, we get that, actually, let me say, we get that from the generative aspect, this ability to see things in the world as something in particular, rather than as something else. Okay, let's keep going. navigators want to choose 3 lines of position for their next fix. Those lines don't exist yet, but they need to judge the angles between them. They do this by gesturing on the chart. And you could say, well, you could do it in visual imagination. Why gesture? The reason we gesture is to create lots and lots of representations in different modalities, different sensory modalities, and they're all congruent with each other. That is, they all have the same content. So here we are gesturing. Congruent is good. I think it gets us a stability of representation that we wouldn't otherwise have. Here's a case where a navigator had an aha insight, and I believe it came from the fact that he actually had 2 quite different representations in different modalities that were complementary. They were related to each other, but they weren't quite about the same thing, but they combined to create a new conceptual object that hadn't been experienced before. So complementary relationships across modalities, the content of modalities, I think is a source of creativity and maybe a source of insight. I don't think that's been well investigated yet. Back in the world of aviation, here's 2 Japanese airline pilots with a Boeing instructor pilot, and they're imagining the aerodynamic effects of recovering from an approach to a stall. And what you're seeing here is actually a pilot anticipating and actually gesturing before the instructor does a concept that the instructor is building. And this tells us that they inhabit a shared conceptual world, a shared world of experience, and they not even within one individual, but now across individual, we have relationships of the contents of modalities. The incredible thing about this setting as well is the richness of the representation that they all share. So when the instructor is talking to a pilot who will sit in the left seat about trimming the airplane, he uses his left thumb because that's where the trim control would be for that pilot. Talking to the other pilot, he uses his right thumb. When they talk about retracting a speed brake, there's a slight rotation in the wrist, and that's because operating that control involves that slight rotation. So a very, because they are multimodal, continuous, and generative, they're continuously generating expectations about this shared world. Once we have eye tracking, this is just a little example where one pilot is looking at a chart and saying what they're going to do on an approach. The other pilot is looking at a waypoint list, and in the eye tracking, we can actually see that projection of a trajectory onto a spatial array that we originally saw in the navigation world, especially in the 3-minute rule example. So that, and again, that's something that's provided only because we have a generative system that can project this structure onto the world. Let me finish with an example from the work of my colleague, Christine Johnson, who studies bonobo chimps. In this example, we see a chimpanzee infant that's being carried, gets off its mother's ventrum and moves away and makes a gesture to solicit being picked up to be carried again. And if we do an analysis of the various sensory modalities that are involved in this, we again find complementary contents in modalities across individuals. The infant here is engaging in a complementary, not an imitative relationship with its mother, and the solicitation is separated. It's removed from the act of being picked up in space because it's away from mother's body, in modality because mother is seeing this visually. She never experiences the actual carry as a visual experience. It's separated in time because this is not the moment of the pickup, and the dynamics are separate because it's frozen. And those are 4 ways to move this away from the act to this, what becomes an icon. So if we can move with this multimodal, generative, continuous framework, we can now see how we could move a representation away from the thing it refers to. And I don't know if that's what it takes to get us from act to icon. Maybe that'll help us understand what it takes to get from icon to symbol. So I imagine a cultural ecosystem of cognition. It's interesting that culture and the brain both make experience more predictable. Learning in the brain improves the match between predictions and sensation. That's what generative AI does. And cultural practices contain a bunch of mechanisms for increasing the predictability of experience. So in a way, the brain and culture are both in the same business. They're in the business of controlling the uncertainty of experience. And at one point I wrote to myself a little note. I said, meaning is always expected. And I realized I could read that 3 different ways. I could say meaning is always expected in the sense that this generation of expectation is the only way we make meaning. We could say that meaning is always expected, emphasizing the fact that all our sensory modalities are continuously generating expectations. And we could say meaning is always expected, meaning that this is a sort of meta expectation. We expect that our expectations will match our sensations. So I presume that most of you who logged into the Zoom today logged in expecting some meeting, and I hope that I satisfied your expectations. Thank you.
Thank you so much. Are there any questions from the audience? Yes, Sadi?
So thank you very much. This is a lot of food for thought. So what I understand from the talk is, because a temporal succession in real experience correlates all aspects of and modalities of what happens, if we capture all aspects, as you showed in the beginning of your talk, you can get the correlation between all the aspects of a situation, right? And so this is actually how AI learn, just as we learn, okay? And so this means first that you could get modality translation in the prediction, right?
Mm-hmm.
In any kind of modality, as long as you have this continuous recording, which you showed how to track. And the other one is that you could actually get all the correlations from context to action, right? So basically you have with AI, as long as you have a multimodal recording of what happened, a way to explore the material to see all possible connections between what's in the context, I mean, from any part of the situation to any other, right? Right. So what is it you want to do with it? Do you want to confront that to the way people do actually interpret themselves? Do you want to use that as a predictive system? What do you want to do with it now that we have that possibility?
Well, all I want to do, actually what you've described, I think, is an important research project, but I think it's not what I know how to do. All I know how to do is to look at what people do in the real world and to try to better understand why their behavior is organized the way it is. But I don't even consider my MGC framework to be a theory. It's not really a theory of anything, any more than the other tools that I used earlier, a physical symbol system or a propositional calculus. I don't consider those for my own work to be theories, but they're ways to change the nature of the cognitive ethnography that I'm engaged in by focusing my attention on certain things. And I think for me, the virtue of, especially the generative aspect of generative AI, is a focus on what's happening on that interface of the organism with its environment, whether it's and the details of all the different senses that are involved in that.
Okay, thanks.
Wonderful. Andy now?
Thanks, Ed. That was great. I really enjoyed it. I guess that, I agree with you that culture and brain conspire to make experience predictable. And that seems to me hugely important. I was wondering about something like the other part of that puzzle, that we got all these cultural practices that kind of curate useful amounts of uncertainty, that generate prediction errors that are going to be informative and useful for learning. And that seems to me to be the other side of it. And I wondered whether there would be an obvious way to apply this sort of multimodal generative continuous framework to curating useful uncertainty.
Yeah, that's a great comment. And I actually did have a little list of processes that are involved that actually allow for or encourage the increase of entropy in experience. And so I think it'd be really good to curate a much better set of those. I mean, some of them are obvious. Being 75-year-old myself, I'm becoming aware of cognitive decline as a as a mechanism that increases the uncertainty of experience. But there are lots of others, and I think you're right that many parts of culture don't reduce the entropy of experience, and that some of those, and maybe even things in humor and other kinds of insight and generators of surprise are important parts of culture. Yeah.
But maybe they curate it in just the right places where uncertainty will drive really good bouts of learning. There's something interesting there about the way we structure schoolrooms, for example.
Yes.
Yeah. Great. Yeah. Thank you.
Great. Thanks, Andy. Good to see you.
Good to see you.
Wonderful. Tyler?
Thanks for that fantastic talk. Great to see that wonderful career overview. And you made a really nice point at one point about the mutual accommodation within generative AI between prediction and perception. These are sort of both adjusted within the systems to better match. And it seems like a lot of cultural systems, cultural practices are much more stubborn. And there's a kind of, long-term temporal stability to them that is, maybe a benefit. Maybe that's one of the ways in which they're so good at reducing entropy. I just wanted to hear your thoughts about that mutual accommodation that seems really central to generative AI systems that maybe seems a little bit more lacking in cultural systems, as and whether that's a bug or a feature.
That's a hard one. If I understand correctly, you're asking about places where we don't get a good accommodation between expectation and sensation.
And just maybe that, the reason why you can get that in a generative AI system is because it's built in that it's constantly trying to, reduce that gap.
Right.
Some cultural systems seem a little bit less friendly in that regard, right? They sort of recruit our brains to play a particular role. And then, we either play that role or we get booted. I'm
sorry, can you give me an example? I'm a really concrete thinker.
Yeah. So, I'm thinking about, sort of like queuing up in line to go into a store, for instance, or engaging in maybe collaborative mathematical practices, where the cultural systems that we're recruited into, they kind of like really, really fixed, expect people to play very fixed roles. And that seems really stable over time versus the somewhat rapid adaptation that you see within generative AI systems, and sort of just thinking about that tension between stability and sort of not adapting versus kind of rapid adapting. And
right. Okay, I got you now, and I thank you for bringing up the question of queuing, because I think that's one of the very best examples of this. One of the features that a generative system gives you is the projection of a trajector onto a spatial array, and we do that with queuing. As you know, that's how a bunch of people become a line or a queue that has a beginning and an end, and you can say who's where in the line. And yeah, you're absolutely right. Some of those are, I think, overdetermined. And I mean, they're so multiply determined. If you look at cueing, there are so many environmental supports as well as cultural supports. There's even a morality of cueing, of course. Cutting in line is considered to be some kind of moral offense. So that's, yeah, I agree. There are super stable structures. And then there are other cases where we're just sort of working it out on the fly. And we don't have a sort of overdetermined preset procedure or well-developed practice. And I had a lot of what I'm working on, but I didn't have time to put in here as properties of a larger cultural cognitive system, where one of the things would be how do such stable structures arise and what keeps them stable? And this goes back to a question that Andy addressed in a bunch of his work a decade ago or so. How does this assembly, do little ecological assemblies that solve a local problem, how do they get put together? And my argument has always been that they're put together as part of an ecosystem that has a whole lot of constraints impinging on it. And with this multiple constraint satisfaction, even if you don't already have a stable plan available, you can still pull together on the spot a solution. But if you do have a stable protocol, let's say for something like cueing or I don't know, it seems like ensemble music playing is it maybe depends on the genre. Maybe there is a stable form for chamber music that doesn't exist for jazz. But so I think that's a super important question. And I didn't really have time to talk about it too much here. But yeah, it's one of the places where I'm trying to go in this month. I have here at the Institute. So if somebody out there has some good ideas, I'd appreciate all the help I can get.
Great. Thank you so much. Unfortunately, that's all the time we have today for this talk. So thank you so much, Professor Hutchins, for joining us today and during this month.